In this section, we're going to be solving equations. Now you will notice that the equation that I've given you over here has got fractions. And the first step in order to solve the equation is to get rid of the denominator. If I take a look at the denominators that I have in this equation, the first two denominators are very nice linear factors. In other words, they are fully factorized. But the third denominator is not fully factorized. And so my first step must be to factorize the denominator of x squared minus 1 by using the difference of two squares. So if I do this, the first term remains as it was, as does the second term. But the third term, when I factorize the denominator, I'm going to break that down to two linear factors of x plus 1 and x minus 1. On the right-hand side, 9 over 4 remains as it was. Now I'm able to find my lowest common denominator. I use my lowest common denominator in order to get rid of the denominators in the equation. Now finding the lowest common denominator is a process that I'm going to follow. To do this, I need the most of each type of factor. Remember, you can get three types of factors: a number factor, a variable factor, or a bracket factor. And in this particular equation, I have a number factor of 4, and I have two bracket factors, one of x plus 1 and one of x minus 1. The procedure that we're going to follow now is we're going to multiply every single term by the lowest common denominator and cancel common factors from the numerator to the denominator term by term. In other words, I'm only going to write down the factors from the LCD that could not have been cancelled with each denominator's factors. Let's do this together. In my first term, I had an x in my numerator, and I must times that by 4 and the factor that couldn't have been cancelled, which is x minus 1. The way that I do this is I take a look at my old numerator and I check and see from its old denominator to the LCD what are the factors that were in the LCD that it hadn't had before, and I multiply the old numerator by these. So in this case, I've got 2x that's got to be times by 4, which gives me 8x, and also needs to be times by x plus 1. Moving on to the next term, it had both of the bracket factors in its denominator, and so the only factor that would be left over is the 4, and this must be multiplied by the whole numerator. And then lastly, on the right-hand side, I had the number factor of 4, and so 9 must still be multiplied by the two bracket factors. In my next step, I'm going to multiply out all of these brackets. So distributing 4x times x is 4x squared. And then I have minus 4x plus 8x squared plus 8x minus 4x squared minus 12. And as I have three factors on the right-hand side, I first need to multiply my brackets, which would have given me x squared minus 1, and then times 9 into those terms, which gives me 9x squared minus 9. You can see that this looks like it's going to be a quadratic equation because I have got x squareds. So I'm going to take all my information to the left-hand side and make it equal to 0. The two terms on the right, when they are taken across to the left-hand side, change their sign, and so 9x squared becomes minus 9x squared, and minus 9 becomes plus 9. And now in my next term, in my next step, I'm going to add like terms. So that you can see how I'm going to add these terms, I've color-coded them. And I'm going to write down my answers in a reducing degree of x. So I'm going to add the x squared terms first, which gives me an answer of minus x squared. And then adding my x terms, I get plus 4x. And lastly, adding my constant terms, I get minus 3. All of this is still equal to 0. Now, when I want to solve this quadratic equation, it's very difficult to use the trinomial method while my x squared term is a minus. So I'm going to take out that minus as a highest common factor and change the signs of all my terms. In the following step, I divide both sides by that constant. Now I'm allowed to divide by a constant because it doesn't affect the solutions that I'm going to get. And if I divide both sides by minus 1, the minus 1 cancels with the minus 1 on the left, and 0 divided by anything is still 0. You can see you can use your trinomial method here to factorize. And factorizing, you're going to get x minus 3 and x minus 1 as your two factors equal to 0. The quadratic equation is going to give you two solutions, because if x minus 3 is equal to 0, then that means that your first solution could be when x is equal to 3. And if x minus 1 is equal to 0, your second solution could have been when x is equal to 1. But are both of these solutions going to be valid? In order to find this, I'm going to go back and take a look at my LCD. You'll remember that your LCD was all the factors that were used in your denominator. Now there is one number that you can never have in a denominator, and that is 0, because you cannot have a 0 denominator. It makes any fraction undefined. So going back and looking at my LCD, I need to know what restrictions I would have. Every factor that has a variable in it creates restrictions. 4 obviously is not a variable, and so there would be no restrictions on 4. But the restrictions that I've got are created by the two bracket factors. The first bracket factor of x plus 1 could not be 0, and so then that means that x was not allowed to be minus 1. The second restriction came from my other bracket, and that too could not be equal to 0. So in other words, my x solution could not be 1. At this stage, the warning light should be going, because you should notice that one of the solutions that I got was, in fact, when x was equal to 1. Well, I'm not allowed to use that. So in this example, the equation only has one solution, and that is when x is equal to 3.